Yes, hi there. So this is a video that I want to show you how do we do the intervals like in the textbook, and this is on page 63. And here you can see we have three different kinds of intervals, but the author sort of take shortcut here. Line integral, you have one integral, but if you have a surface integral, you must have two integrals. And here is a volley integral, should be three ones. And but just be careful when we deal with these integrals. So this video is going to show you how we're going to choose the directions here. Did you see this weird R like these directions, and how do you simplify them? And you can just hear that depend on different situations, the way that we choose them also different. So let me start one at a time, and I want to show you total. We have three parts essentially. We're going to deal with that. So I'm going to show you the one example, and after this, so let's first look at the some of these exercise that we deal with. You see this particular problem, which next page we did not assign it, and we deal with these twos also. All right, so I'm going to show you the first the line the charges. So in this case, just like the first integral that I'm going to use, and it's a little bit non-trivial because even the line charge sometimes is also involved two-dimensional. But I want to show you three parts. So when I say three parts, what I really mean is that here it depends on the r itself, r prime itself. So integral itself has to be over r. R prime, sorry, over r prime itself. So now I'm going to show you the general features of these integrals, and you should be very careful. First, any integrals that you do, you always have a charge. Suppose here is where your charge locates, and here is the field point. Let's call it point A. It's over here, and here is where the charge is situated. In other words, all the integral itself should be over this particular part. So we, as I said in class, we integral over r prime. And here's the field point, and typically we want to find the electric field at the point A. Now we are going to choose the origin over here. So this is our origin. So then you can see you have two vectors like this. One is over there. It's called RA. That's vector. Another vector is where this charge is situated. Let's call it R prime. R prime vector. So then you see the difference vector, which is called a delta R. I prefer to R A minus R prime. So like this. So let's call it delta. So this delta is really R A minus R prime. And this first video, what I'm going to show you, what's the general ideas, how you are going to do that. So the general idea, so here I'm going to write this down. There are two different ideas which is involved. First idea is with respect to this denominator, which is R minus R prime. That's deal with this part. Second, we're going to deal with these unit vector, which is RA minus R prime divided by, sorry, this should be squared, R prime, like this. So that's how to deal with these general ideas. And so in this case, the integral always have a little bit non-trivial things involved. Was that you have inside of integral you have this R. We don't like this R. It's essentially the R sub A. And we don't like these. We want to get rid of as much as we could, but not completely, because if you get rid of completely, you are not calculating the electric field at this particular location anymore. So that is a challenge. So we're going to start with this one simpler first. This part is going to be the one that we're going to start with first.